Hello students, good evening to all of you. So here I'm going to solve one problem from system of particles in rotation motion, Ncert question number 6. So in this problem, find the components x, y, z axis of the angular momentum of a particle whose position vector is r with components x, y and z. And momentum is p with components px, py and pz. So basically we have to write the components of angular momentum. So as we know that angular momentum L is equal to r vector cross p vector. So we have to find out the components of L, x component, y component and z component. So it can be derived as I, j, k, and the value of r is written as x, y, z, because your r vector is simply written as x I cap plus y j cap plus z k cap. So this is for r vector, position vector with components x, y and z. Then this is p vector, that is momentum vector having components px I cap plus py j cap and pz k cap. So the components of p are px, py and pz. So then we can easily get the components for angular momentum. So components कुछ इस तरह से आ जाएंगे हमारे पास. I is like y pz minus z py and minus j, it is simply like x into pz minus z into px plus k, it is x py minus y px. So from here we can easily get the components of angular momentum as Lx component can be written as x component of angular momentum is y pz minus z py, and then the y component of angular momentum is z px. Like here we have a negative sign, so we can write z px minus minus plus, and it is minus x pz. And then z component of angular momentum is x py minus y px. So these are the components of angular momentum. So हमसे प्रॉब्लम में पूछा गया था components along x y z axis of angular momentum of a particle whose position vector is r and momentum is with components px, py and pz. So these are the components of angular momentum. Now we have to show that if a particle is moving only in the xy plane, the angular momentum only has a z component. So we have to apply the conditions on these components x, y and z. So condition is such that if a particle is in xy plane, we have to show that it only has a z component of angular momentum. So students, if any of the particle is like in xy plane, so obviously its z position is equal to 0. Particle is only in the xy plane, so no z coordinate will be there. And we can say that if a particle is in xy plane, so no component of movement along the z direction will exist. So no pz will be there, and no z coordinate will be there. So when we check for various cases, like this is our x component, like there is no pz present there, so this comes out to be 0, and there is no z coordinate as well there, so it comes out to be 0. So lx component is not possible. Then we can check for ly component of angular momentum. As we say that there is no z there, this is 0, and then again there is no component of momentum in the z direction because particle is in the xy plane. So obviously x component is not existed for that particle moving in xy plane. No ly will be there. You can easily check that your z is 0, your pz is 0. So because of these 0 values, lx and ly comes out to be 0. So it means that only and only z component of angular momentum is there. So that was the case. So if the particle moves in xy plane, its angular momentum only has a z component because that particle has z equal to 0 and that particle has pz equal to 0. If it is the case, then we only have a z component of angular momentum. Thank you.